Charm.
Is there a
Hi.
town existing? There it is.
Hi, welcome to our Coveytown API project. So for our project, we decided to implement combat inside of Coveytown. And we realized that as you were going around having conversations with people, there was really no way to settle a dispute. And on top of that, Coveytown felt kind of anticlimactic. Like, you can walk around, you can talk to people, but there's not really a whole lot to do. So as you can see people popping in and out here, if I go and join this conversation area, I now have the option to duel all the people that are inside. So if we just all sit here and sit still, then I can either choose to duel every player that's inside of the town, this conversation area, or just one individual person. So if I click duel all players, I get to choose a game mode, and this dialogue is the same one that pops up for both of them. And again, you can close the dialogue, having no side effects, or you can duel someone individually. So if I wanted to duel Harrison, I'm like, oh, never mind, I want to actually duel both players at the same time. Duel all players. And the two games we've implemented are Tag and Wizard Wars. And so this custom modal pops up on top, and when you click on one of the games, you can see that it loads in here. And what's happening here is that it's actually spawning a custom canvas with our own sprites drawn. And some of these are used from tile sets. We made the wand and the fireball. And you get a custom little UI here on the side to choose your moves. And so to send in moves, you just click a button, and it puts a request to make that action, and then immediately updates into the DOM here. And so by updating it this way, when you get a request back, you can see that like, oh, here's these two people fighting. They are having wand battles. So if I wanted to go pick up a wand, I can press up. Now I'm on the same tile as the wand. I click swap. The wand is now in my possession. I'm down. I'm moving around. These are wand spawners. I move up. I move up. I move over. And then I fire the fireball. And you can see that everyone else got collided with and died. And so now I'm the winner. And you can minimize this. And if you're the last person alive and you quit out of the game, then the game ends for everyone. But so say that I died pretty early. So say that I'm going to duel everybody here, and this time we're going to play Tag. Tag is actually a turn-based game. So in the turn-based games, you have to wait until it's your turn to commit your action. So here's me. It says it's my turn now. I want to move left for mine. And you can see that who is, quote, it is has a hovered with a corona around. So let's make sure that Zach doesn't get tagged on this next turn so we can showcase another feature. But I'm going to confirm my action to move to the left. And so now it's Harrison's turn. Harrison could move left and kill Zach, but I'm going to ask Harrison to move right and confirm that action so that we don't immediately end the game. Now it's Zach's turn. Zach's going to just do something that's not moving towards Harrison so that I can go and die first. And now you can see that this tagger has 19 rounds to kill someone, and a round is constituted by everyone making one action. So it's my turn. I'm just going to run into Harrison so that you can see the other feature here. Zach's turn. It's my turn again. Moving my way towards him. Harrison's turn. Zach's turn. And now it's my turn. So if I was careless enough to run right into to Harrison, who is, quote, it, I'm dead. My UI goes away. I have no more ability to confirm an action, and I can keep spectating if I want. Or if I'm in the conversation area and I don't really want to see the game, I can minimize it, but I don't want to necessarily leave spectating. So you can do that here. Or say I want to stop spectating altogether until, I'm like bored, I'm a sore loser, I don't want to watch. I can quit out of the game, and now I have no ability to go back and spectate. So that's our feature. Those are the games we've implemented. It's all rendering on a custom canvas here, and now we can do a little bit of a code overview. So if we go to the code here, to showcase off some of the UI, we can start by the different components. So it all starts in world map, which is what is dealing with actual requests to the API, which is on our backend, and we have a pretty strong separation since it is a REST client between our front end and our backend. And the state of the board is returned back as a board state type, which also actually might be helpful to go to the front end types first and just show you what we're working with as data structures. So as you can see here, we've got quite a few different types. We've got a direction, an action type, an action. And action types are the kind of actions that you see selectable in the UI, which is either you can do nothing, you can move, you can use, you can swap. You can pick up certain types of items. These are the ones we've implemented. Particle types, bullets, fireballs, etc. Some nice like little cover wrappers, so like a number, and we're just calling it an index, so it's easier to work with. And then the idea of sprites, and you can get into all the nitty-gritty of this if you want to go and look at the actual code itself. But as a high level, we returned from the API a board state. And this board state holds all the information necessary to render it on the client side. So none of it is actually happening besides the rendering on the client side. There's no logic being deduced. Everything is happening on the server and just being rendered on the client side. So that's why if it lags or something like that, it's still waiting for a response. So back in the world map, you can see we have a bunch of these use callbacks so that we can asynchronously resolve these inside of use effects to send requests to the API endpoints. So we have 3 endpoints: send action, create board, and end combat. And these are the public-facing ones. So obviously they're pretty well named. So create board will create a board. End combat will end combat for you, for that singular person. And then send action will send your current locked-in move. And the actual logic for what those things are is determined by the backend. As you can see down, we have a few different UIs. So we have the select game modal. And if we want to go take a look at that, that's right here. And that's just a little modal that comes up with the 2 buttons. And each of those select the game types. If you want to go to the board is probably the most convoluted, so I'll go back to that after a second. And then the other piece we have is the battle UI. And the battle UI is pretty simple. It's just a bunch of different buttons with some custom styling and some custom CSS sheets over here as well, where each button has a set player action command, and it'll set the action with the action corresponding to that button. So you can see here. A possible refactor is to render these conditionally based on like how many actions you have. If you had an array of all the actions you could do. But this was really good and was pretty extendable for all the things we needed it to do. Then finally the board here, and this is the most complicated one. The actual HTML for it isn't all that complicated, or the JSX rather. Here we've just got the quit or close button, so we have the header up here inside of this H-stack. Then we have another H-stack, which is the actual player UI. So that's whether or not you can see rounds left, the whose turn it is, and here you can say where the winners are and your confirm action button. And then the heart of it all is in this canvas element. And now to gain access to a canvas element, you can use this reference thing so that the reference hook is given from the useRef React hook, and this will return an actual mutable reference to the object, so you can use it later. Then we're requesting animation frames, and so what this will do is this will run once every whatever frame rate the browser supports by default, and every time it runs, it'll call draw, and our draw function is what all of this code is. And we don't necessarily need to go to the nitty-gritties of it, but at a high level, we first clear the canvas, then we draw the sprites. So we draw the ground everywhere, then we draw the obstacles, and these are all coming from the board state, then the items on the ground, and then we draw the players. And then this is a big convoluted code to draw the corona around who is it, if that's necessary. And then finally after that, we draw all of the player items as well. So that's the drawing. Yeah, then the player items. And then we also draw the player names too, which was a nice feature that we added so that you could actually tell who is who when you're playing the game. And if you have any projectiles, they get rendered right at the very end. That's pretty much it for the front end, so we can move over to the back end now. And I can just open up a new window and go to my recents. And as far as the back end goes, we've got a few different endpoints, and so we've got pretty much all of the data types cloned here on the back end as well. So we're working with the same language back and forth, and we're not getting confused on what data types are what. For the actual combat, we've got this abstract class, and this abstract class is implemented as an interface here, where we require you, in order to have a playable game, to define move combat, includes player, remove player, number of players, game is over, and update the win condition. As long as all of these are implemented and you have defined sprites, you can have and add any game that you can conceive of right into your Coveytown. So as an example of this, most of the things are implemented by default in the abstract combat controller, but in wizard combat controller, like the one with all the fireballs, you can see the only things that we updated were the constructor, so we can actually spawn items, because tag doesn't have items. So by default, we don't want items to be on the board. And then the update win condition. And so this just is basically where you say, is the game over yet? And so here we march through and see if anyone was hit by a particle. And if they were, we remove them right here. And if all the other players are gone, then besides one, or if they're all gone, then the game is over and there's a winner. Just like that. We also have implemented some Coveytown request handlers. And these are handlers that get responded from these API requests. And we have these API requests defined right up here. So custom, just like this, we cloned the defaults. Are they up here? They're in a different file, it looks like. But the general idea is that they accept these request handlers, and they're wrappers for all the different endpoints we have. So end board handler, move board handler, and create board handler. Coveytown controller. Here we have the actual things that are called, the methods that are called here. And where are these endpoints implemented? It's in the town service client. Yes, it's in the town service client. And these are where the actual endpoints that get hit are. So we resolve these promises right here. And yeah, that's pretty much everything, every part of our code base. Thanks for listening in.